Welcome to our comprehensive session on Introduction to Agentic AI. Today we'll explore the evolution of AI systems from simple chatbots to sophisticated autonomous agents. This session will equip you with the knowledge to make strategic decisions about AI implementation in your products and understand the transformative potential of agentic systems. So, what will you learn today? Our learning journey today covers 5 critical areas. First, we'll establish clear distinctions between different AI paradigms. The precision is crucial for your decision making in context of product decisions. Second, we'll deep dive into what makes agents tick, their architecture and core components. Third, we'll examine real case studies to understand practical implementations. Fourth, we'll discuss about the opportunities and risks to help you implement safely. And finally, we'll look ahead to understand how this technology will reshape product development. The AI landscape is filled with confusing terminology. Terms like bots, assistants, copilots, and agents are often used interchangeably, but they represent fundamentally different capabilities. As a tech leader, our mental model must be precise because a chatbot can't do what a copilot does, and a copilot is not an autonomous agent. This distinction is vital when choosing which AI paradigm to use for specific needs, whether that's user experience enhancement, support automation, developer tooling, or strategical decision making. Now let's start with the chatbots. Chatbots are the simplest and the most familiar AI systems. Traditional chatbots are rule based, relying on keyword based matching and scripted flows. They are purely reactive, responding only when prompted, with no real memory or planning capabilities. Think of them as sophisticated phone trees. They excel at narrow tasks like answering frequently asked questions or triaging support queries, and they break down quickly when you push them beyond the predefined scenarios. They don't reason, they don't adapt. Their strength lies in speed and simplicity for specific repetitive tasks, but they are fundamentally limited by their programming. For example, here is a simple flowchart of a rule-based chatbot decision tree which follows a clear and sequential path based on user input and predefined rules. For example, in this case, this is the sample flowchart. Um, at a certain point, the user input is received. So, two keyword or phrase matching rules are applied, and if a certain rule 1 is found, a certain predefined answer 1 is fetched and returned to the user. Similarly, if rule 2 matches, the certain predefined answer 2 is sent to the user. If rule 3 matches, a clarifying question can be asked, and further we can have user responses to clarifying questions. Then we can have sub answers, sub rules, sub rule A, sub rule 2, based on the specific information provided by the user. And in case no match is found, so the system can restart. It's like a typical IVR. Now coming to copilots. So copilots represent a major leap forward. They are built on large language models. They are embedded inside applications to assist users with smart context aware completions. Think of GitHub Copilot suggesting code as you type, or Notion AI helping you to summarize your notes. The key difference here is that the copilots understand your current session context and offer intelligent suggestions. However, they don't pursue goals or take initiatives independently. They don't remember long term objectives across sessions. Copilots are designed to enhance productivity while staying firmly within the user's control. They assist and suggest, but they don't plan or decide autonomously. Now coming to agents. Agents are the most sophisticated form of AI systems. Agents are autonomous systems which are capable of operating towards a goal without a constant user input. They think, they act, they observe, and they reflect in continuous loops that allow them to adapt to new information and make decisions on the fly. Unlike copilots, agents use external tools like APIs, retrieve knowledge when needed, and retain memory access tasks and even sessions. An agent might be given a high level goal like planning of a marketing campaign, and it will independently research competitors, analyze market trends, develop strategies, and generate a comprehensive report all autonomously. Agents represent the most powerful AI systems we have today, but they are also the most complex to design, deploy, and govern safely. Now, this is a capability matrix between chatbots, copilots, and agents. So these are the various parameters on which each of them are judged: memory, autonomy, tool use, goal pursuit, learning, complexity, and use cases. We'll also discuss capability comparison on a heat map. So this comparison matrix clearly illustrates the progression of capabilities of AI system types. Chatbots have no memories, no autonomy, no tool use. They simply respond to inputs based on predetermined rules. Copilots are significantly smarter with session based memory and the ability to use context, but however, they still operate within the narrow scope and require user guidance. Agents, in contrast, have high autonomy, can use external tools and APIs extensively, and are capable of pursuing long term goals independently. If your product needs persistent reasoning, multi step workflows, or decision making autonomy, you are looking for agents, not copilots and not chatbots. Understanding this hierarchy is crucial for setting up appropriate expectations and making the right architectural decisions. Like you can see across the heat map, agents score 5 on 5 on each of the parameters. Copilots are in the middle, somewhere around 3, and chatbots are in the lower rung of the hierarchy. Now this is an interesting comparison. This is a scenario just for sake of discussion. For example, your assistant knows how to open an umbrella when it rains. But what if the weather changes and it gets extremely sunny? How would they behave in this scenario depending on whether the role is of a bot, copilot, or an AI agent? So, this is the premise. So, what is the behavior in the given scenario? For bots, bots simply open the umbrella only when it rains as defined within the scope. Copilot suggests using an umbrella for sun but waits for the user to approve. AI agent recognizes the heat, evaluates the umbrella's material and autonomously open it for shade. So that is the difference. Definition, I think we discussed that. Scope of knowledge limited to fixed scope for bots, broader scope for copilots, but they need user guidance. And AI agents are the most capable of the lot, integrating contextual data and external resources. Adaptivity Adaptability cannot adapt to situations outside the predefined scope, provides intelligent suggestions but relies on human intervention, and fully autonomous. Decision making, again, no decision making for bots. Co-pilots have decisions which depends on the user's final choices, and AI agents are independent. Execution of tasks are simple in case of bots, and user still has some amount of control in case of co-pilots, and agents plan and execute complex tasks autonomously. Learning capability is static for bots, dynamic for co-pilots, and dynamic and self-sufficient for AI agents. Now let's come on the next topic, which is choosing the right paradigm. So let's get to it. When designing an AI powered product, You must start by understanding what you are really building. A chatbot is an excellent tool for instant Q&A scenarios. A copilot can significantly elevate user workflows by providing intelligent assistance, but only agents can truly operate on your behalf towards a goal with minimum ongoing direction. The key is setting expectations accordingly. Don't promise autonomous behavior from a copilot tool, and don't deploy an agent where a simple chatbot could suffice. Evaluate your team's readiness, technical infrastructure, and risk appetite very carefully. Often, the best part to begin is with copilots and evolve them to agents as your capabilities and confidence grows. This evolutionary approach allows you to build expertise, establish safety practices, and demonstrate value before tackling the complexity of fully autonomous systems. Now let's discuss about agent architecture, which includes tools, memory, and goals, the foundation pillars of an agent. So what gives agents their unique power and architecture? Unlike simple interfaces, chat interfaces that just respond to prompts, agentic systems are structured to act autonomously towards goals. This capability rests on these three fundamental pillars that I already told: tools, memory, and goals. Tools enables agent to go beyond the text generation and take real action in the world. Memory allows them to retain context, learn from experience, and maintain continuity across the interactions. And goals provide direction and purpose, driving the agent's decision making processes. These three components work together synergistically, with the tools without the memory leading to disconnected actions, memory without the goals lacking directions, and goals without tools remaining unrealized intentions. So if you decouple any of them, it would not work. When evaluating or building an agent system, always ask these three critical questions: does it act through the tools? Does it remember through persistent memory? Or does it pursue objective through defined goals? Only systems that can answer yes to all three demonstrate the true agency. This is an example from text to action. So here is a user. A user interacts with an AI agent. Backend there is an LLM. AI agent sends API calls to suppose Gmail, Calendar, Google Calendar, OneDrive, and then on the back end there is an authentication with the Google server based on the token exchange. And suppose the user sends in a query regarding suppose a mail related to a certain appointment, and based on certain file on the Google Drive, that can all be retrieved and processing can be done. Natural language can be understood by LLM, and to retrieve all this language, to retrieve all this content from Google, of course they need API calls, and they also need this user to be authenticated. So this authentication workflow is through OAuth based on token exchange. So this is just one use case. So tools are what enable the agents to go beyond text generation and take meaningful action in the real world. An LLM by itself is fundamentally static, and it is only usable to generate language, analyze text, and reason without concepts, but it cannot do anything concrete. Agents, on the other hand, are equipped with tools that can use APIs to update CRM records, scrape websites for current information, run code to analyze data, manipulate files, and send communications. This capability requires sophisticated decision making. The agents must determine which tool to use for each situation, when to invoke tools in its workflow, how to handle failures or unexpected responses. Tools use is perhaps the most defining characteristics of an agent, because it's what allows them to execute tasks and deliver tangible results rather than just generating text. The scope and sophistication of an agent's toolkit directly determines its practical capabilities and business value. Now, coming to memory. Memory systems are the foundations of learning. Without memory, agents would be perpetually stuck in the present moment, unable to learn from the past interactions or maintain coherent multi step reasoning. Memory systems are essential for any sophisticated agent behavior. There are several types of memory that the agents utilize. One is Scratchpad, which acts like a whiteboard during task execution, allowing the agents to keep track of intermediately steps and reasoning. It's kind of like a temporary memory. Then there is a long-term memory which persists across tasks and sessions, enabling the agents to remember user preferences, past interaction, and learned insights. This memory capable is used to allow the agents to evolve and improve over time, rather than resetting after every new interaction. However, implementing memory systems bring significant challenges around the storage efficiency, privacy protection, and appropriate scoping and management of what should be remembered versus what should be forgotten. When designed well, memory systems enable personalized experiences, continuous learning, and the kind of relationship building that makes agents feel like genuine collaborators rather than tools. Okay, goals, the driver of autonomous behavior. Every effective agent needs clearly defined goals. Goals provide direction and purpose, determining which tools are needed and how memory should be utilized and what should the reasoning paths be to follow. Goals can range from a simple like generating a document summary to highly complex like developing comprehensive market entry strategy. The sophistication of goal management directly impacts the agent's effectiveness. Well designed agents can decompose complex goals into manageable subtasks, track progress against milestones, and dynamically replan when the circumstances change. Goals can be nested hierarchically, with high level objectives broken down into specific actionable items. This goal driven architecture is what enables truly autonomous operations. The agent can work towards objective without requiring constant supervision or micromanagement. Without clear goals, there can be no autonomy. For team building agent systems, defining appropriate goals is often the first and the most critical step, as it shapes every aspect of the agent's behavior and capabilities. From automation to adaptation, it's a paradigm shift. So, Agentic AI represents a fundamental step change in what we expect software to do. For decades, software has been about predictable automation. If this condition occurs, execute the predetermined response. Even with machine learning, most systems were built to optimize fixed output like scoring leads or classifying images. Agentic systems operate differently. They can take a loosely defined goal and autonomously figure out how to reach it. This introduces a more dynamic, adaptable layer to products that can evolve and interact intelligently based on context and objectives. Instead of building rigid features with predetermined user flows, we are now creating systems that can understand intent and generate appropriate workflows on the fly. This paradigm shift reshapes how we think about user experience design, moving forward from task based interfaces to outcome based conversation with intelligent systems. Now, how agents are collaborative partners? How can they act as collaborative partners? So this is the schematic of a organization tree of a organization tree that can be for an organization using agents for various processes. Suppose there is a human supervisor and an agent supervisor, then they can be multiple human agent and supervisors. Then they can be an agent based team, they can be a mixed team, and they can be a human team. So at various levels and hierarchies we can have these different roles assigned in an organization. The big opportunity with agentic AI isn't just better tooling, it's gaining new kind of digital teammates. Agents can operate like junior team members with specialized role. like research assistants who gather and synthesize information, project managers who coordinate tasks and track progress, quality analysts who review work and suggest improvements, content creators who handle documentation and communication, and data analysts who extract insights and generate reports. These AI teammates can work independently on routine tasks and provide 24/7 operational support and scale team capabilities without requiring any additional headcount. This allows human team members to focus on more high value creative work, strategic thinking, and complex problem solving. The cultural shift is significant. Instead of using passive tools that wait for instructions, teams begin delegating meaningful work to AI partners. This requires developing new skills around effective delegation, establishing appropriate trust levels, and creating verification processes that ensure quality without micromanagement. So, transforming workflows and user experiences. So, this is a typical agentic workflow. We have a user query through a UI. Inside agentic workflow, the agent makes a plan, executes action using tools with the plan, then it reflects on the results of the tool or whatever action that it's taken. If the results are not okay, it amends the plan and this cycle continues. In case the results are fine, the results are sent back to the UI as a response, and this cycle can continue. Product managers and designers should pay close attention because Agentic AI has the potential to transform both internal workflows and end user experiences simultaneously. Internally, agents can automate research synthesis, generate documentation, perform quality assurance tasks, and optimize project management processes. This allows teams to move faster, maintain higher quality standards, and focus on strategical initiatives rather than operational overhead. Externally, agents can drive personalized onboarding experiences, provide intelligent decision support, and offer proactive assistance that anticipates users' needs to deliver sophisticated support that goes far beyond scripted chatbot responses. These improvements allows you to build products that are not just reactive tools waiting for user input, but proactive partners that anticipate needs and take initiatives. This shift represents a series of uh, competitive advantageous steps in markets where user experience and operational efficiencies are key differentiators. So, this is a brief overview of the key takeaways of today's session. We discussed about what is agentic AI. First of all, we discussed about the objectives. We discussed about what is agentic AI, a new paradigm of AI focused on systems that autonomously pursue goals, make decisions, and adapt to real world complexity. Then we discussed about differences between chatbots, copilots, and agents. Then we discussed about tools, memories, and goals, the basic agent architecture. Finally, we discussed about why agentic AI matters. Coming up in part 2 session, as in the next session of the same series, we would discuss AutoGPT, the viral prototype, LangChain, the development framework, Crew AI, multi-agent collaboration. Then we'll understand technical fragility of agent AI, autonomy and safety risk, framework and development challenges, risk management, safe deployment, paradigm shift, which is the task to outcome based design, emerging implementation patterns, product team competitive advantages, leadership and strategical transformation, executive debate framework, and some next steps related to agentic AI. Thank you everyone for your time. Hope this was informative. We'll catch you in the next session. Thank you.